This video is to show you the calculation steps for question 36 to question 40 on your computer basic quiz. The first one, question 36, what is the binary equivalent for the number 26? Please show your calculation steps. You can refer to slide 6 on Model 1, Digital Content and Media. This is an example of how to convert from a decimal number to a binary number. I have write down the calculation steps here, but let's come back to our question. Okay, the number is 26. So let me put the remainder here. Okay, the first step is divide 26 by 2. The result is 13, and the remainder is 0. Keep on doing this. Divide 13 by 2. The result is 6. Remainder is 1. And divide 6 by 2. Result is 3. Remainder is 0. Divide 3 by 2, result is 1, remainder is 1. And divide 1 by 2, the result is 0, and the remainder is 1. Okay, we should stop here because the result of this division is already 0. And this one is the most significant bit, and this 0 is the least significant bit. We should read this column from bottom to top. So 26 in decimal is 11010 in binary. That's for question 36. Question 37. What is the decimal equivalent for 0011011101? Please show your calculation step. You can refer to slide 7. This is an example of how to convert from a binary number to a decimal number. Come back to our question. Let me copy this number to my Word. Okay, we should multiply the digit from right to left by the value of the placeholder, x power of 2, and then add those numbers together to get a final result. For this one, we should start from this one. So this one should multiply by 0's power of 2. And this 0 should multiply by first power of 2. This 1 multiplied by second power of 2. This one multiplied by third power of 2. We have another 0 here. This 0 should multiply by fourth power of 2. And we have another 2 here. This one multiplied by fifth power of 2. And finally, the last one multiplied by sixth power of 2. And then add those numbers together. So 0's power of 2 is 1, so this is a 1 and 0, 4, 8, 0, 32 and 64. Final result is, okay, this is 96, 13. Okay, the final result is 109. So 1101101 in binary is 109 in decimal. Question 38 to question 40 are for either audio or video file calculation. Question 38. What is file size for 2-minute 2-channel uncompressed audio such as WAV if the bit deep is 16, sample rate is 96,000 Hz? Please show your calculation step. You should refer to, this slide 16. So here, uncompressed audio file size should be calculated as bit depth multiplied by sample rate multiplied by number of channels multiplied by duration. This is in second. Then you will get how many bits bit that audio file has. If you divided this number by 8, then you will get how many bytes byte this audio file has. Okay, so this one should use 16 multiplied by 96,000 multiplied by 2 channel multiplied by 120 seconds. The result is this number. This is how many bits the file has. 368,640,000 bits. Let's divide this number with 8 to get how many bytes this file has. This number is still very large. Usually we would not say, okay, this file is 46,080,000 bytes. We will represent it in KB or MB. I suppose for this one we should represent it as MB. Okay, so this is a tricky part here. How many bytes a kilobyte should have? Well, the prefix kilo means 1000, right? Third power of 10. Per this definition, it is very common that you think, okay, 1 kilobyte is of course 1000 bytes. This is correct. So we can say this number is 46,000 kilobytes. You can also write it as KB. Oh, please pay attention to this unit here. This K is a lowercase letter k. This B is a capitalized B. So you cannot use a lowercase letter b here because a lowercase letter b means bit. So capitalized B means byte. However, when referring to digital memory capacity, kilobytes can also be considered as 1024 bytes. That's actually 10th power of 2. This arises from the powers of 2 sizing common to memory circuit design. So in this context, we can also say we can divide this number with what? With 1024. We can also say 46,008,000 bytes is 45,000 kibibyte. So actually, I think this one is more popular. But if you want to use kibibyte, you should write it as this KB. So both K and B should be capitalized. So either number is correct as long as you use the correct corresponding unit. This number is still kind of too large. Yeah, we want to say, okay, this file, this MP3 is 46,080 KB. So we'd better keep on converting it to MB. Okay, so here, if you want to stick to this set of units, you should divide this number with another 1000, which means it will be 46.08. It is called megabyte. But this time you can use this MB. So both M and B are capitalized. Or if you want to stick to this set of units, which means you want to use the base as 10th power of 2, 1024, you should divide this number again with another 1024. Okay, the result is 43.95. It is called maybe. So this time, you can use MB for both. I don't know why, but just for KB, those two units have difference here. So either you divide this number with 1000, or if you want to divide it with 10th power of 2, you should use 10th power of 2 twice, which actually means 20th power of 2. So you cannot use 1000 and next time you use 1024. Okay, please stick to a certain set of units. Okay, this is for question 38. Question 39. What is the file size for 4-minute MP3? MP3 is a compressed audio at 320 kbps. Please do your calculation step. Okay. Calculation step is on slide 17. Compressed audio file size is bit rate multiplied by number of channel multiplied by duration in seconds. Then you will get how many bits. And if you divide this number with 8, you will get how many bytes. So in our question, okay, this is kbps. 320,000 multiplied by number of channels. Since I didn't say this is a 2-channel MP3, you should consider it as a 1-channel by default. 1, and the duration 4 minutes is 240 seconds. Okay, the MP3 has 76,800,000 bits, which is 9,600,000 bytes. Okay, now you can convert this number to KB, either 9,600 kilobytes or you can divide this number with 1024. That's 9,375 kilobytes. Either is fine as long as you use the correct unit associated with reason. Okay, last question is what's the bitrate for 640 multiplied by 480 resolution, color deep, 16 bits, and 30 FPS video? And what is the file size for 1 minute of such video? Please show your calculation step. Okay, I think you should go to, this last slide. First, we need to calculate the bitrate for that video. Bitrate is resolution multiplied by color depth multiplied by frame rate. So that will be, say, bit rate is 640 multiplied by 480 multiplied by color depth is 16 FPS is 30, right? So the result will be this is how many bits the bit rate is, and the file size of course is bit rate multiplied by duration. One minute, 60 seconds. This is a really large number. Divided by 8, still very large. I think this time we should convert it to GB, gigabyte. So as I already mentioned before, you either stick to the 1000 base or you stick to the 10th power of 2 base, which means you either divide this number by 1000 3 times. The result will be 1.10592 gigabytes. Or you should divide this number by 1024 3 times, which actually means 30th power of 2. Okay, this is called GB byte. You can use capitalized G and B for both. Again, I want to emphasize it one more time. Both numbers are correct. You just need to pay attention to the unit you use. So since MB and GB, those two are the same, right? So if you want to use MB or GB, you need to specify if it is a megabyte or megabyte, if it is a gigabyte or gigabyte. I know it is a little bit complex, but this is how it should be. Okay, let me. So, okay, this is all calculation steps for those 5 questions. 1, 1, 2, 3, 4, 5. Okay, that's all for this video. Thank you.